Alright, the next topic is graph features of polynomial functions, and I've broken this topic up into two parts. So, part one has three objectives, as you can read here, and in this video I'm going to talk through objective 1 and objective 2. So as you're working through these two videos, you should consider this. If given a graph of a polynomial function, students, or you, should be able and will be able to, first objective, determine the domain and range, and second objective, determine the end behavior of the polynomial function. So, a couple things to consider with domain and range. Understand that domain refers to the horizontal x-axis, the x values, and that range refers to the vertical y-axis, or the y values. And then know the phrase left to right when I say that refers to domain, and that floor to ceiling or bottom to top refers to range. And then for objective 2, end behavior, understand what direction left or right this is referring to. This notation right here is read as x approaches positive infinity, f of x, or the output is what? And that's what we're looking for. And then as x approaches negative infinity, the output, f of x, is what? And we'll talk about that more in detail in just a second. So, moving on, let's talk through some key terms that I'm going to speak out loud or talk about, and then I want you to be able to know as well when you hear the word domain, range, or end behavior. And so for domain, again, it's horizontal, left to right. You read it like a book. It's the x-axis. And I care about the x values for domain. Range is vertical. And I can say top to bottom, or I'm sorry, bottom to top. Or floor to ceiling if you consider a house, something like that. It's the y-axis. And it's the y values I care about for range. Alright, and then end behavior. And this is what that notation down here is saying in words. So, as x, or the input, approaches negative infinity. Negative infinity means we're going to the left direction. What then is the output, y, doing? Y can also be written as f of x. Same thing, as x approaches positive infinity, to the right this time, the end point at the rightmost point, what is the output doing? And again, it could be written as f of x. So those are things to consider for domain, range, and end behavior. End behavior is just that. What are the ends doing? There's always going to be two ends that exist in a polynomial function, so what are they doing? The leftmost end and the rightmost end. So let's go through an example then. Part A is domain and range, and so if I was going to do domain and range and model how to do it, first for the domain I have to be thinking about what I just learned. Domain is horizontal, and I read it like a book, left to right, so it's the x-axis and the x values. So if I start at the leftmost point, reading like a book, I see that it's down here somewhere. But if you can safely assume that if it's not noted otherwise, that these endpoints go on forever. So the leftmost point will continue going down, and then if you notice, it is going to the left, just not as drastically as it's going down, but it is continuing to go to the left as well. So the leftmost point is going to the left forever and down forever. And so, to the left forever, if you remember, is all the way to negative infinity. And so I'm going to write in interval notation, negative infinity is my leftmost point. Now, let's go to the right-hand side, because we read left to right. And so the right-hand side, it's the same situation. It's going down forever, and it's going to the right forever. And so to the right forever is positive infinity. And so I'll write positive infinity for the rightmost point. Now that's the first way to write that, but because it is technically negative infinity to positive infinity is all real numbers that exist in this function, I can use this symbol as well. All real numbers, and that looks like a funny R. All that means is all real numbers satisfy this domain. So I'm done with the domain, the leftmost point to the rightmost point. Now the range is a little bit different. It's still the same thought process. I'm going to erase what I did for the domain, or at least that part. The range is, again, if we go back to our notes we just took, it's the vertical, bottom to top, y-axis, y values. Okay, so the bottom, like we just talked about, goes down forever. Both these points are going down forever. So I know that it starts at negative infinity. And I start with the bottom, that is just the rule, so always look at the bottom first. And it goes to this time, if you read this, ride this roller coaster of this graph, it's going up, 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 but it stops and goes back down. Same thing over here, up, 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 but it stops and it goes back down. So this range does have a top or a ceiling. The ceiling exists right here. It's the same point on both sides of the graph. So at that point, I have to consider the y value at these 2 points. And the y value, because the range is y values, is 1, 2, 3, 4, 5, 6, 7, 8, 9. The y value is at 9. So I know that this range stops at 9. So the entire range is from negative infinity to positive 9. Another way you can write that, so that's the first way, this is the second way for domain. First way, second way, is that all x values, I'm sorry, not x values, we're dealing with range. So all y values, and you need to know both these notations. Y value is less than or equal to, because it actually touches 9 right here, less than or equal to 9. So if you see this, all y values are less than or equal to 9, so that means all y values below 9 exist, because it goes on forever, or negative infinity to positive 9 means the same thing. This is just interval notation and inequality notation. So that's domain and range. Let's talk through end behavior now. And this is the last thing I'm going to do in this video. So I'm going to go ahead and erase my notes for domain and range. And then end behavior. So again, if I was thinking through end behavior, I would notice there's 2 ends. And it's read left to right, same as domain. There's an end here, and I know that it goes on forever. And an end here, and I know that it goes on forever. So the first one right here is x, the input, approaches positive infinity. I know that from our notes, positive infinity right here is going to the right. So positive infinity is the input, the x values approach positive infinity. What's the output doing? The output is going down. So the output approaches negative infinity. It goes down forever. As it approaches, and that's, I know that's a little tricky to think about, but as x approaches in positive infinity, so as it approaches this direction, positive infinity, it's going down. So it's just negative, and it's going all the way down to negative infinity. Same thing here, and it's not always going to be the same thing, but in this case it is. As x approaches negative infinity, so we're going to the left now. Negative infinity. What's it doing as it's approaching negative infinity? The end point down here is also going down forever. To the left forever, yes, but also down forever. And so I know that down forever means it's going to negative infinity as well. These won't always be the same thing every time, but in this case, that's the example. So at this point, go ahead and try the you do problem down here example, and try A and B, and raise your hand when you're done so I can come check your work.